Welcome back to James's Physics 101. I'm Albert. Today we dive into Einstein's happiest thought, the equivalence principle, the profound insight that gravity is not a force, but geometry. Imagine you are inside a windowless elevator in the deep void of space. Away from any planets, you feel weightless, floating freely in the center of the cabin. For centuries, physicists noted a strange coincidence. An object's resistance to being moved, its inertia, is exactly equal to how strongly gravity pulls on it. Why? Suddenly, a rocket engine starts accelerating the elevator upward at exactly 9.8 meters per second squared. Everything inside is forced toward the floor. You drop your watch. To you, it falls to the floor just like it would on Earth. Your feet feel a solid pressure, indistinguishable from standing on solid ground. Einstein realized that no internal experiment could distinguish between being accelerated in space and sitting in a uniform gravitational field on a planet's surface. This is the equivalence principle. It tells us that gravity and acceleration are two sides of the same coin, fundamentally the same physical phenomenon. To see the consequences, imagine a laser beam crossing the accelerating cabin. Because the cabin moves up while the light crosses, the light hits the opposite wall lower than it started. From your perspective inside the cabin, the light beam has curved downward. If acceleration and gravity are equivalent, then gravity must also bend light. This was a staggering prediction. It meant that even though light has no mass for gravity to pull on, its path would be altered by any gravitational field. In 1919, Sir Arthur Eddington led an expedition during a solar eclipse to test this. They measured the light from stars passing near the darkened sun. The stars had shifted exactly as Einstein's math predicted. Gravity didn't just pull on matter, it dictated the path of light itself. But how? Einstein's answer was the fabric of reality. Gravity isn't a force reaching across space, it is the curvature of space and time themselves. Light always takes the shortest path between 2 points. In a curved space-time, that shortest path is a curve. Gravity is simply the shape of the universe. This equivalence also implies that gravity slows down time. Light climbing out of a gravitational well loses energy, shifting its color toward the red. Einstein called this the happiest thought of his life because it linked everything, mass, acceleration, space, and time, into a single elegant framework. From this seed grew the general theory of relativity. These equations describe a universe where matter tells space how to curve and space tells matter how to move. This isn't just abstract math. Your smartphone's GPS must account for these gravitational time shifts, or your location would be off by kilometers in minutes. So next time you feel the weight of the world, remember, you aren't being pulled. You are simply following the natural curvature of the cosmic fabric. The equivalence principle bridged the gap between the familiar world of falling apples and the strange reality of warped space-time. It is the key to the cosmos. In our next lesson, we'll take this curvature and explore the fourth dimension. Get ready to master the 4D fabric of reality. I'm Albert. Keep questioning the nature of reality, and I'll see you in video 6 of Space-Time and Relativity.